Hey everyone, we're back at you with another game development project. This time we are going to be making a army simulator video game. What that means is that we're going to have a central unit that will exist in a world that can recruit other units into its army, and it can engage in combat with armies of other factions. We're going to be adding some custom stuff on top of that as well, but that's the basic premise of it. So we're going to go ahead and start. We have UE4 open. We're going to create a new project. We are going to use the top down template as a basis for this. The reason why is because this will take care of our overworld, which is what we're going to start with. And we're going to use this as the basis of our overworld. We're going to go ahead and give this a name. I'm just going to call it Army Simulator. We're going to say desktop console, maximum quality with starter content. However, even if you still want mobility, you will get it even in desktop. Really, the only reason you would specify this is if you're making a game specifically just for mobile and tablet. But if you're doing both, do desktop and console. And we'll go ahead and create some starter content because we're going to be using some temporary assets. As always, not the best at creating assets. This is more of a tutorial about programming than it is about creating assets. So we'll be using a lot of stock assets. In fact, we'll be using a lot of shapes and basic stuff for a lot of the things in our game. And if you're hoping to see skeletal meshes, unfortunately, probably no skeletal meshes in this series. We'll be sticking to static meshes. Even this stock skeletal mesh that we have here will be removed. But let's go ahead and let's see what we get from the default game. So we get our top down, we get some mouse control, and we can click, and we can move. The way this movement works is called the nav mesh. And if you ever hit P, if you ever select inside the map and you hit P, you will see the nav mesh. And the nav mesh gets generated dynamically. And this is how AI knows where to move, including our character. When we click, it knows how to move because of this mesh that gets generated. And this gets generated automatically. So if I delete that box there, you'll notice the nav mesh has already said that, hey, this is now valid terrain. But you can see the areas right here where there isn't the nav mesh. That means we can't move there. So AI and our character is only going to be able to move within this nav mesh. So we're going to go ahead and click P. We're going to do that, and we're just going to show an example of that. So we can move here because the nav mesh is fine, but we can't move here because the nav mesh says we can't access that spot. So this is basically all the system we need really for an overworld. We just need to be able to move somewhere and get there and be able to navigate through collision. As you can see, there's navigation and stuff. If we hit a wall, it does path around it. Also, you might notice the shadow here remaining. This is more of nothing to do with, this is not really an issue. This is just the lighting. If we were to build and rebuild our lighting, that will get fixed. And if we were to ever package our game, that would not be present in the final game. And we're building our lighting now, 98%, and it's gone. But that's how baked lighting works, by the way. If you ever heard the term baked lighting, the lighting literally gets baked into it. So we're going to go ahead and we're going to make some adjustments to this template. The first thing that we're going to do is we are going to make sure that our camera is a little bit higher because I feel like this is a little bit too close to our character. We want to be zoomed out and we want to have a lot of view around us. So the way that we're going to do that is we're going to edit our character. Now, if we actually just select our character in the game world, we can go to our world outliner over here on the right, and it'll say this is what type of actor this is. So we'll go ahead and edit this right here. We will parent this to our main view pane by just dragging it in there, and we will take a look at our class. So this is the character that we're controlling by default. Everything here is just stock in UE4, but you'll notice that we have cameras here. This is where we actually view it from. One of these cameras is actually for the VR camera, which I'm not going to worry too much about, but the other one is for the one that we view when we play the game normally without VR. Now we can move this camera up and down, but that is the incorrect way to do it. The reason why is because this camera that we see attached to our player is actually attached through a spring arm. And we want to adjust the spring arm. And we can go over to the right here and we see target arm length. And what we will do is we will set this up to, let's say, yeah, let's do 1200, almost double what we had. I think it might have actually been double. I think it was 600. I wasn't paying attention. It might have been 900 or something. But it's now 1200. And now we have more distance. Now, the reason why we want to do it through here is because the spring arm is made specifically for this purpose. Because if you ever have a game where, like, take a look at a third-person game where you go into a corner, you notice your camera zooms really close into your head. The reason why is because the camera object is actually literally colliding with the wall, and it knows to move further in. If we didn't have this capability, what we would see is the camera would clip through the wall, and you would see all the backside of the terrain mesh. In fact, in older games, you can do that quite easily, and even in modern games, you can still have the camera clip through walls and stuff, although that's usually failures in these types of systems. So the target arm length is the length that it will try to always be at. However, if there's something colliding in the way of it, it'll get close. It'll get as close as we can get to the player until it's like right on top of it. Now that's not going to be a problem too much in what we're doing, mainly because we're going to be top down, isometric. There's not going to be like really anything in the way. But anyways, we go ahead and click play now. We will see we are much farther out. And in fact, you know what? I want to be moved even farther out than that. So we will do 1400. And we will play again. Yeah, that's about right. Okay, so now we got some basic movement. All this looks good. Everything's fine, nice and dandy. But there are some issues. The fact is that this really isn't a game. Who's going to enjoy this? So we're going to add some AI. And we're going to do that by having factions, because we want this to be like an army simulator. We want it so armies can build up, leaders can get like new entities within their army, and that they can fight other armies of similar type. So there's got to be some things that we got to do and keep in mind. Now I'm going to explain some things that I've already thought of ahead of. The first thing about it is that because Fog of War is most likely going to be a part of this game, meaning that you're only going to have vision on things that you actively have vision of, that you have people nearby to see. Anything that you don't have in within the Fog of War isn't going to be rendered. So what that means is we want to have our logic to keep track of cities and armies in a more structure than an object type or an actor type, specifically an actor being a UE4 specific 3D object, something that exists within 3D space. It doesn't have to be visually representative, it just has to have the 3D space in it. But most of the time it is visually represented. So we got to think about how can we have it so all of this can happen, but we don't need to render it. How can we have logic that looks at city logic? Like an example is like have AI in the Fog of War know what it needs to do without revealing it to the player. So what we're going to do is we're going to have all of that in a more struct type class, or even maybe just a U object, but definitely not an actor. And then we're going to have an actor class that visually represents that data whenever the field of view or the Fog of War is removed over it. And so we're in range, we already have the data in memory, we just look into it, and then it's visible. So that's what we're going to primarily start with. So we're going to go ahead and create some classes. And we're going to go ahead and create a new folder here. We're going to say custom, and this is just going to be all of our stuff that we add to this project. And we're going to go to blueprint, and we're going to say a struct. And I'm going to do s underscore to just identify this as struct, and we're going to call this factions. Now, we're going to be very, very basic with our factions. We're not going to get too hardcore, but we are going to create some stock factions, and we're going to do an enum with that. So we're going to enum stock factions. And we are going to define these literally by their color, and their names are literally going to be like off of the color that they represent. So we will have the Regulons, because they deviate from red. We will have the blue bows. Should it be like blue bows? Blue bows. We will have the greenlings. we will have the Purpulons, and we have the Regulons. We can have Purpulons. I like Purpulons better. We'll say the Purpulons. The red, the red, the Redivians, the Redivians, the Blue Bows, the Greenlings, the Purpulons. Feel like we should have like a yellow. Hmm. It's just so hard to make because yellow is such a big word. So red, blue, green, purple. You know what? We'll just start with these. This is fine. 4 factions. These are our factions, and we are defining them through enums. And the reason why we're defining them through enums is this in Blueprint. Yeah, this stuff where we're starting with is all going to be a tutorial series in Blueprints. But if you're familiar with C++ and you're not experienced with Blueprints, everything's the exact same thing. The nodes are called the exact same things that you would call in C++, with the UE4 engine, and even operators are the exact same thing. The example is that you're in, C++, you want to do a for loop. You got your for loop. Well, there's a for each loop. Let's actually get a for loop. If you want your Boolean operators, Boolean OR, you got these in here, and you can validate them through branch conditions and stuff like that. Answering a question to Shikama Gaming, by the way, because I forgot I'm recording, so I probably should not be responding to people. No, not to be rude, but unfortunately, it looked very odd in the video when I just start responding to random people all of a sudden. But anyways, that's I should actually bring that up. If you are someone that's new to UE4, you know C++, C#, don't worry about it. Pretty much all the node names are going to represent all the C++ functions that are in there. Everything follows the same structure. It's just a more visual approach that's easier for people that are newer to programming. But all the same practices in traditional programming still apply. So we have our stock faction. We have our faction structure, and we're going to go ahead and do that here. We're going to make our first type of our faction. Did I save it? Did it get saved? We're going to take a look. Oh, it's East Stock Factions. That's right. There we go. And we're going to call this name. And then we're going to do something real quick. We're going to go into here, and we're going to go down here, and we're going to say save on compile always. I highly recommend everyone turn this on every time you start a new project, because it's saved per project. And what it'll do is make sure every time you compile that it will save, meaning that you won't really ever lose a lot of data if you crash or something. It saves a lot of time, and you still get recovery options, although you have to do it more directly by actually looking into your save directory and pulling out the autosave files, bringing them in, removing the appended names, and replacing them over the old ones. And you get up to 10 revisions, I believe is what it is. It'll keep up to 10 past revisions of when you last saved it in history. So you get a pretty big grace period. So we got that there. We're going to need some more things about it. We're going to need to know their color. We're going to go ahead and have their color code. And this is just going to be a int value. We're going to say color code. And this is literally just going to be the hexadecimal code for their color, just so we can get in. Actually, now that I think about it, because we are not just doing solid primary colors, this actually does probably need to be a proper color. Do we want linear? How do we process this? This is fine. We'll just do color. We will do the color. What else do we need? Well, we can just leave this for right now. I mean, this is really all we need. We will go ahead and we will take a look at our logic for the world. All right, so there are some things in UE4 that dictate some things globally. The map itself has some code associated with it, and that's called the level blueprint. So you can go to open level and actually access the logic for inside the level, anything that's tied to it. However, I like to keep that stuff tied to stuff that's only unique to that mesh that you're using. Otherwise, I would highly recommend that you do something else. A second, just closing some stuff out, bringing back some stuff over to the right. Okay. And so what we are going to do is we're going to um, spawn in these factions. We're actually going to have them come in, and they're going to be in the game. And we want to do that not in the level blueprint. It's kind of an odd place to do it, in my opinion. Instead, what we're going to use is we're going to go to our main game mode. And if you go down, you see it says top-down game mode. I'm going to go ahead and select this, and I'm actually going to change this to Overworld. I'm going to call this Overworld. We're going to go in here, and we're going to do some very basic stuff here. The first thing that we're going to notice is if we go to Event, Begin Play, there's nothing happening when the game starts up. This gets called every time that we actually instantiate this here. So what we're going to have happen is we're going to spawn factions. So let's spawn, we're going to create a, actually we're going to do this in a more object-oriented way. This might seem a little bit weird to do if you're not too familiar with object-oriented principles, but what we're going to do is we're going to create a class that's going to encapsulate all this logic. And the reason why is just more for code clarity to make sure that all the code specific to factions is going to be within this one class, and everything deviates around that. We're going to go ahead and do blueprint. We're going to say blueprint class. We are going to say UObject. No, wait. UObjects can't spawn actors because they need world context unless you do a wrapper function, which gets it a little bit messy. So actually, we are going to make this an actor just for ease of it. And we're going to call this Faction Manager. Go to Overworld. We will then say spawn actor from class. We will say Faction Manager. Get we can't get a transform from here, so we'll say make transform 0, 0. And then we spawn this in our faction manager. We then need to have our faction manager do something. So we are going to go to our faction manager, and we're going to create a function. And we're going to call this function initialize. And the reason why I like to do functions that initialize rather than do constructions on event begin plays and stuff like this is just generally down the line you'll need to have some you'll have some race conditions where you'll need certain things to initialize in order, or you may need to be able to reinitialize them. So this is more of just like a practice that I do. It's not something that you need to do. You could have this logic on event begin play and it should remain exactly the same. However, I'm looking down the line where I most likely will be moving this. So we have our initialize logic. We go back to our overworld. We then call initialize, and we ponder if we saved it, but we did, so initialize did show up there. So whenever the overworld begins, it's going to spawn this. So let's go ahead and click compile. Wait, got to compile this one first. I did not save it, but somehow it knew to do that. Nice. So we're going to go ahead and click play, and you know what? Our game doesn't look very different, doesn't it? Looks pretty boring, right? But if we go in here, you'll notice we have one overworld. So this drop-down shows you any instances of the class that are active in the game. So if I click stop right here, nothing. I click play, overworld. And that's because it's spawning right here. Now, if I break this here, or I'm sorry, this is actually happening from our game mode. So actually what we want to look at is our faction manager. And you see faction manager there. You see it is instantiated. Now to just prove this, we're going to go ahead here and we're going to unhook the spawn actor node. We're going to go back over here, and when we click play, what we will see is that there will be nothing in here because the actor no longer exists. This is very useful for debugging in UE4 because you can select instances, any number of instances of actors, and then see their properties in the editor. So to clarify that, we're going to do something like this. I'm going to just for an example, I'm going to have it, hey, every time you spawn this, wait 2 seconds or 0.2 seconds and spawn it again. Now watch happens when we go over to Faction Manager. Look at that. See how it just keeps adding new ones? So every instance of this actor we can have direct access to within our blueprint and look at it at runtime and look at its variables and stuff like that. So that's one thing that we're going to be utilizing quite a bit. Also, you can see all the classes are literally appended with the number instance of that class. So very rudimentary naming logic there. That's all built into UE4. But we'll go ahead and delete this because we only want one faction manager. We will never need two. We initialize, and then we're going to go ahead and we're going to spawn factions. We're going to go ahead and say get. Oh, I'm sorry. There is one thing that I forgot to do. So we need a data table. We skipped a step here. So we're going to go to our custom. We have our enum. We have our faction struct, and we need a data table. And we are going to go to miscellaneous, and we are going to data table. And you'll notice when we select this down that our S faction shows up. Any struct that you have will show up here. Even if it's a C++ struct, it will show up in this. Well, as long as it's a C++ struct that has the uClass property blueprintable or blueprint type. Either of those might work. But anyways, once you get here, we select this, and we click OK. We now have a data table that is of this type. I'm going to go ahead and name it DT factions. And we're going to here, and we're going to actually create our factions. Because all we did was create, before with the struct, all we did was create like a template for our factions. We created the data, the restrictions on data, and how we interpret that data. That's what we defined, but we never actually instantiated any of the data. And that's what we're going to be doing right now. So we're actually go ahead and we'll call this, we're just going to double up and actually use the names I have here. So Redivians. Their color is going to be red. Now, there's one thing missing here, though, is that we need to make sure our alpha is always 1 here, or else nothing will actually show up. It'll be invisible. So we got that. And then we click Next. And then we will select our blue bows. We will call them the blue bows by their proper name. And we will make the blue bows, as you guessed, blue. And I'm going to do this all just manually through these sliders here. And they are blue. We will then add the greenlings. And, as you might have guessed, the greenlings will be green. Okay, and then we will go to a new one, and we are going to say the Purpulons. The Purpulons. Purpulons. And the Purpulons are going to be purple. Now, there is no like hard set color for purple, so what we're going to do is 0, 0.5 there. We'll go to our blue, 0.5, and that is apparently what pure purple is. I mean, yeah, I guess that's pure purple. Okay, so wait, my alpha was off. Also, look at nice floating point precision in happening in real mode. Even though I type 0.5, once you save it, floating point precision comes in the way and makes it all messy with these decimal places. Okay, now we have our data table. So we go to faction managers. We're going to say for each loop, we're then going to say get data table row names. And we're going to select our faction. We're going to say for every data table row name, get the data table row, which we have to pass the name, which we will pass through here. Also have to specify the exact same data table type. So this is a little bit, if you're not too familiar with programming, what we're saying is that at runtime, look at this data table and get all the rows and return all the names of the rows. And we return them. I'm going to move this over here a little bit. We're going to just clean up our top bars real quick. Where's our map? Where's our map? There it is. Oh. So we're getting a list of all the names in our data table row. And that's what these boxes mean. This means it returns an array. If you're familiar with C++ or pretty much any programming language, actually, you're going to be familiar with arrays. That's what this visually represents. We then say for each loop, which is something you'll be familiar with C# and with certain versions of C++ or a lot of programming languages, is that we can then say, do a set of logic for every instance or every element that is in this array. Element would be the more correct term. And we then say, okay, pull us all the data for that row that we're looking at currently. And then we break out the data, which then gives us the actual properties. So we can do stuff with this. One of the things that we're going to do is we're going to be setting the color. So we're going to be making all of our characters spawn different colors, so we can tell, blue bows are going to be blue, purple bows are going to be purple. So just by looking at them, we will know which ones are which. And that's the first thing that we're going to have that's unique about them, is that they're going to spawn in, but they're each going to be different colors. And to do that, we are going to need to change something about our top-down character, which once again is the character that we control, but it's also going to be the same character that the AI is going to be controlling, because we're just going to be spawning these in and giving them to AI. We will go ahead and we are going to say, we need to take a look at our skeletal mesh. We need to then look at our main body material, and we're going to see what we can do to change this. Now, you'll have to pardon me. I'm not too good with adjusting things through the material editor, because I am not a material person. I'm more of a programmer. However, this looks like it's actually already been set up quite appropriately for us. So there is a parameter called body color that all we have to do is change, and that's it, and it'll apply to these here. So that's very, very easy. We will go ahead and we're going to say, before I type this, let's explain it out. So the next thing we got to do is we actually got to create instances of these. And just like how we were doing in our overworld, where we're spawning an instance of Faction Manager, in our Faction Manager, in our initialized logic, we're going to be spawning the instances of the factions. And it's all going to be happening so quick and within one event that it'll happen before anyone realizes it. They'll exist in the game before anyone's the wiser. It'll look like they've always been in the game. And so we'll go ahead and we're going to say spawn. Well, we're going to right click and say spawn actor from class. We are then going to specify that class that we have, and we're going to say top down character. And we might have to spawn a controller for it, an AI controller, but we will find out in a moment. I can't quite remember. We will get get random vector. Can I get a random vector? And cone degrees, and elliptical cone, and radians. Random box, random point in bounding box. This is what we're looking for. Okay. What we're going to do is we're going to have these just kind of spawn randomly. We're going to say make transform. We do not want to spawn them in the air, so we are going to make sure we're never setting the Z. So we're going to say make the location here. And we are going to be taking a look at a random value that is between negative 1000 x, negative 1000 y, 1000, and then 1000. And we are going to give the box a depth, but we don't care about it. The only reason I'm giving it as a depth is because sometimes, or there was a bug in the past, I think it's probably fixed now, where if you had these at 0, it wouldn't process a lot of the logic correctly. But just to make sure we're not getting any sort of Z value, we're going to keep this 0. So what we're saying is, hey, get me a random point within negative 1000 and 1000 for the XY, and then we're going to spawn this actor at this random location. Now, these are world coordinates, which means that when we go into our world, it's going to be relative, like off of here. It's going to be within 2,000 units, 1,000 units to the left of the origin, up to the right of the origin, or up and north and south, not up and down, north, south, east, and west, but not vertically. We will then go back into our many classes that we have all over the place. We're just going to organize a little bit here. Into our faction manager, we're going to our initialization logic. We will have that here. And we are going to go ahead, and now that we spawned this character, we can actually get a reference to this character from this pin here. This is what this purpose of the return pin is, that you created a new instance of this. Here is its reference. Now, what its reference is in UE4, it is a GUID, which kind of works like a pointer. It's a pointer with an extra step. It's a pointer with an extra step for good reasons, though, because it works through replication, which means it works through networking, which is really cool. You can have pointers that work online through multiplayer and stuff like that, which obviously wouldn't work traditionally because not everyone's going to have the same memory values, and the addresses of where my HP is stored in my system is going to be different than yours. So that's one thing to keep in mind there. But we're going to go ahead and pull out this reference, and what we're going to do is say get skeletal mesh, maybe just mesh, get mesh, variable, yes, get mesh. And then we're going to say get material index, nope, get material wait, can I just do, I can't do set body color. No, I have to get the material. So get material index. I don't want that. Don't get material slot name. This isn't it, right? Nope. One moment. I'm forgetting how to get. Wait. Oh. Just get material. I apologize. We will then say set body. Oh wait, no. Cast to. What is this? For. Oh, how am I going to get this param here from this? And this is why material person is always good. We got this set param. Oh, but that's right. That's right. There is, okay, we do set param, set scalar. Wait. Scalar param material get base material get scale, nope, scalar variable. We're gonna have to look this up probably. So what we're trying to do is there is a way. Let me see. Can I just do set scalar parameter value? This is what we want. This right here. Where that can't get plugged into there. Material parameter collection object. Or no, there's a set material parameter. No. We're going to have to look this up. One moment. I apologize. UE4 set materials scalar parameter. I probably have to store it as an instance. I have to store it as an instance now that I think about it. I think that's it. Yes. Okay. So this is my fault. We go here. We go to event graph. We will go to event begin play. Actually, we will go to our construction script with event construct. We will take out our mesh. We will get material, create material instance. Wait. Oh. And then set scalar. Yes. Okay. This is what we wanted. We will say material instance is going to be UE4 man body. There we go. And then, wait, we don't do that. We then say promote to variable, and we will call this body mesh. Body mesh material instance. A little bit of a sloppy name there, but it's fine. It'll do. We ain't gonna sweat over it. And we're gonna continue on with this, and we will go to our overworld, back to our initialization logic, and now that we are here, we don't need this. Instead, what we do is from our top-down character, we then say get body material mesh material instance. So this is the reference that I just had. And because this is on the construction logic, this will always exist 100% because the construction logic happens during this node here. So it happens after this execution wire, but it'll process and complete before this execution wire. So this will still be fine. So we go ahead and say set scalar parameter. Now this is the thing about this. The way the system works in the way that this can even work in the first place is that it can take any material, but it can also take in any parameter. Because if we hard coded it and we wanted like procedurally have this here, we would have to do this big class hierarchy system. And that's a little bit too robust for what we need. So UE4 just has us a way that we can directly get any sort of parameter based off of a string value and adjust it. In this case, it's a scalar parameter, scalar meaning that it goes between 0 and 1 normally. It can go between -1, and it actually can go between any sort of float value, but normally you try to keep it between 0 and 1. It is scalar. It is off of a scale. That's what scalar means. It's literally it. It is of scale. But anyways, what we are going to do is go back in here, take a look at it, realize that this is going to be body color. Go back here. We're actually going to see set vector. We actually want a vector. We don't want a scalar because I realize 0 through 1 doesn't make sense because we want to set an RGB color, which is 3 values. RGB. Actually, it's 4 because we have an alpha. It's RGBA. We'll try to paste what we copied here. It will not paste. That's fine. Oh, wait. That's because that's what I copied. We will then take this color here, plop it into there. It will automatically convert. The reason why is because this is a linear color, and this is a color structure. The difference between these is this one's 8-bit, this one's 32-bit. I believe that's it, but that's fine. We're not too picky. Okay. Now, if everything worked right, when we click play, stuff should have spawned, but it didn't. It didn't. So we'll take a look. Top-down characters. Well, they spawned. They're definitely there. So that means that they are not. They probably spawned under the world, which means that this template may not be at 0. It is not at 0. Okay, that makes sense. This is above at 117. So what we will do is we will go to our faction manager, and you know what? Just because they're going to spawn up in the air just a tiny bit, but they'll fall down. There we go. And look, we see the Redivians, and there's the blue bows, and there's the purpulons, and then the greenlings. Look at them. Look at them spawning. Also, looks like I probably didn't do, unless I got really unlucky. It looks like they're all spawning at the bottom left. So my random logic is messed up. Wait, what? Positive, positive. Wait, you know what? That's probably 0, 0. Probably everything's messed up. Why is everything not, or, oh my god, nothing is zeroed out. Wait, this is a 0 though. Everything should be spawned around here then. Something's messed up with my math. What could cause this? This looks right. But you know what? We're not going to worry about it too much. Wait. No, Z is up. I was thinking maybe Y might be up for a little bit, but I was like, no, Z is always up in this. Okay, so we have our factions, but they don't really do anything. Let's make our factions do something. So we're going to take our factions, blah, 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 or we're going to go to our top-down character, and there's already built-in variables that do this, but we're just going to do something. We're going to say is NPC, meaning that it's not controlled by the player. We're going to make this instance edible, and we're going to say exposed on spawn, but we're going to keep the default to false. The reason for that is because we want to make sure that we are not spawned in with this logic, but we will then go to our faction manager, and if we go to our spawn actor top-down character and I click refresh here, you'll see that this is now set there. So I can set the default for anything that gets spawned through this logic. You know what, to back up a little bit because I went through that a little too quick. But the way I did that is in any variable that you create, you can say instance edible and expose on spawn. Those two things are what you need. And then if you do that, you compile and just refresh the node that you have spawning it, and it'll show up automatically. Now that we have a way to tell which ones are NPCs and which ones are players, we are then going to make it so if they are an NPC, that they do something. In this case, we're going to make it so they move around. Now, there's going to be one problem. Is I'm pretty sure this right here is going to fail, but we're going to figure it out if this is the case. The reason why is because this is going to have no player controller. We need player controller for what we want to do, which is move to target, move target, move to simple move to location. That's what we want to do. And to do that, we need to apply it a controller, which is probably not going to have. But we're going to test this out anyways, and if we do get into an issue, we'll just spawn in a controller and assign it to the player, and I'll show you how to do that. We go up here, we're going to say simple move to location. We are going to make vector. We're going to do a little bit more random stuff. We're going to first get actor current transform, or get actor transform. Just that's the fine. Actually, we're going to make this simple, and we're going to say get actor location. We're going to say get actor location. We are then going to break the actor location. Actually, we're not going to break the actor location. We're going to say random vector. We need a random vector range. It's from stream. Nope. Wait, can I? What's the make of the stream? Nope. Okay, we'll do another bounding box then. Wait, no. We'll just do this. We'll do 2 random floats in range. And actually, this is actually really important. There's a big caveat to how these random functions work. And I'm actually going to show it to you, and we're going to actually use that caveat as a benefit. Normally, this is what causes a lot of people headaches when they encounter this problem. A lot of people consider it like a bug, but it's not. It's the intended way of how this works. But let's go through. Let's just show this out. So we're going to make a minimum value of -500 and a positive of 500. So we have a max range of 1,000, -500 to 500. Meaning that -500 will make us move either south or the left of us, or not to the left of us, but east or south, and then positive values move us north and west. And we are going to take our current location, we are going to break this, and then we are going to add the value onto it. Now, negative values added onto a positive value still subtracts, so this will still work perfectly fine. We're going to be going left and right and everything. We're going to add this here, so we're adding that value, and then setting our X location. So we've already determined where we're going to randomly move, when where we're going to be at our X location for it. Now all we got to do to get this is we just do this here, and this here, and this here for a Y. And we don't care about the Z. The Z doesn't matter. We'll actually get our current Z just to make it somewhat similar. But this is where someone's going to be like, wait. But there's going to be an issue here where if, let's say this randomizes a value of 100. then that means you're going to be adding 100 to both your x and y, meaning that every single of your position changes are always going to be 45-degree angles because both the x and the y are going to be modified by the exact same amount. When that happens, you can literally... Oh!
You got paid?
Shout out to Achita Games. Thank you for following. And then... Ooh, got another one. Shout out to Retrozen for also following. Got a little bit of Cho and Nikki there. Every time someone follows a random video game character, up to like from 20, will play along with some corresponding video game music. See which one you get when you follow. I do like Cho and Nikki. That song, I think it's called like Flaming Heat. Even though Cho and Nikki's like a dumb game, it's a joke game. Flaming Heat is a good song. That song's intense. I like that song. Okay, so we will then go ahead and apply these. Oh wait, let's go back to what I was saying. And it's unfortunate I got distracted by that because this is kind of important. However, that's not the case of how this works. The reason why is because the value generated from this random float in range is generated every time you pull it. And what determines every time we pull it is whenever we use an execution pin. So what we're going to get is actually two different random values from here. And if we did want the same value, we would actually have to cache this. We would set a temporary value to cache it. So this is one thing that throws a lot of people off when they use the random float and range or any of the random values, is that this is going to be generated for each one that you pull out, a random value. If you want the same value, you got to cache it. But anyways, we have this here. We move to a location. We will then say delay for about 5 seconds, and then do the whole thing again. And once again, the random value is going to be regenerated every time this execution pin happens. So we'll go ahead and play, and we'll see if the controllers work or not. I have a feeling they won't. They should have started moving immediately, but we'll wait for 5 seconds. Yes. And now probably what we're going to see is when we exit out of this, we're probably going to see some errors about some null pointers. Or maybe not. Maybe not. I was expecting errors. There were no errors. Anyways, I believe this is because we have not spawned in player controllers. It's been a while since I've done this, so we'll go over here. We will say, what do we have to say? Create controller, or what is it? It's going to be a U object, right? It's going to be construct object because it's a U object, I believe. Construct U object from class. Let me actually type correctly. Controller, AI controller. And then we'll do self, doesn't matter. And then we'll say possess. Nope, wait. Why? It's should be top down character. Where do you inherit from? Yeah, character, which inherits from pawn, which I'm going to be launching Visual Studios now because I clicked that. That's fine. But I guess we can confirm what he said. Yep, character inherits from pawn, which means that it should be possessable. What am I missing here? Possesses from the controller. Ooh, good call. Thank you, Achita Games. I hope I'm pronouncing that right. Faction Manager. We will then go to Possess. Corrected Mundo. There it is. Now, there is one. Oh, it's the instigator that I gotta do? I thought it was the outer. Do I have to do both? Wait. Object of type. Construct object from class. Cannot construct object of type. Wait, why can't I construct? AI controller. Do I have to... Do I have to do something like add AI? I don't need a Blackboard component. We're not doing anything that complex as of yet. I'm just trying to do this in a simple way, and we will go for. We'll decide. We'll do this real quick. We'll see if it needs to be an actor. Although it shouldn't show up in that list if that's the case. But AI controller. We will drag this in here. We will get whatever that transform is, and then we do that, and then we do that, and we'll compile and see if we have an error here. Really? Okay, interesting. Has to be an actor. I guess it makes sense because controllers are tied to the replication graph, which does need three-dimensional data, transform data, location data, so it knows when to activate and stuff potentially, I guess. All right, so let's see. So it's not going to happen initially because that event begin play, they're not going to have it started yet. So we're going to wait 5 seconds and we're going to see if this gets called here. And it doesn't look like it, so we're actually going to go into our top-down characters. We're going to select one of our AI characters, and we're going to realize that we are foolish and this is not the Boolean that we wanted. This is the Boolean for head-mounted display, and we are not in VR, so none of our logic was actually being called. We will then replace this with a is in PC branch that we created earlier, the one that we will actually use now. If it's true, we will call this logic. If false, we will do the normal logic. Actually, I guess we'll go down here to maintain VR support, but we will unhook that pin there. We will then go ahead and click play, and we will see what happens. Hey, did you see that? He moved. They're moving. The AI is alive. The Purpulons are invading our territory. So, very basic stuff. This is how we get basic AI. So we're actually not going to need too much AI about this. The reason why is because the AI is going to be a lot of like target driven. It's not going to be incentivized by moving towards targets. There's not going to be too much like we're going to be needing like AI blackboards. In fact, we're going to try to be creating this without the need of any sort of AI blackboard. We're going to try to do as much direct programming as we can. And the AI blackboard is still programming. It's just this more GUI interface that lets you create state machines that determine the flow of logic based off of states and stuff like that. And we're going to do the exact same thing. We're just going to do it a little bit more programmatically. We're not going to go through the AI blackboard. The reason why is I feel like it's a little bit overkill, and it kind of hides some of the things that we're going to be doing. Unlike Blueprint stuff. The thing I like about Blueprint stuff is pretty much everything that you can do here is exact same thing and worded the exact same way as in C++. The only exception that I can really think of is the usage of references in UE4, which in C++ a reference is like a pointer but can't be redefined. It is something hard set and can never be changed. It's more constant. While references in UE4 are GUID based, they're like a pointer with an extra step for good reasons. But this is one thing that I will say that is very different, is that normally in coding you would do like a conditioner of if this is true. There is no like if in UE4. Instead we have branch, which you pass in a Boolean, which you can determine anything from a Boolean. If you are doing comparisons, pretty much everything can be compared, even in classes. If I want to make sure that this camera equals any other instance of a camera, and this is an instance, we're looking at the reference, so once again, this is basically a pointer. If you're into C++ and stuff, essentially a pointer and reference and stuff like that. But we can have it compared to see if this is the exact same, if these share the exact same memory addresses, essentially at the end of the day. And we have nothing to really compare it against, and you would never select something stock from here. You could also get the class type and compare and stuff like that, but basically what you would have is if would be these branch conditions. You don't have else's either, you just do the failing condition to a next branch, or if you have like an enum and you want to do a switch, you can do a switch case, which is exactly like the way it is on well, it's not the exact same way because obviously it's graphical, but it works just exactly like any other switch case that you would use in any other language. You have an input value, and then based off those values, you do certain things. And the way you adjust those values are up here. And you just edit. So if I want to have a string where it says tacos, that anytime that we execute this logic, that if the string is tacos, that we do whatever that we want to do off of this execution wire. And they're all isolated based off of that one call. We will go ahead and delete that there. And we will now go ahead and we're going to do some stuff with cities. We're going to start, we have factions in, they don't do too much. There's not too much to do until we start getting like stuff that they can take over. So we're going to make some cities that they can claim. And what we're going to do is we're going to have it so they'll kind of all know cities exist. Like you kind of have to cheat when you write AI. So the AI are going to know cities exist. They're going to see if they do not have a city, that their priority is to claim a city. That's their number one priority, is to claim a city, to get some foothold in the area. And then once they've claimed a city, they'll just stand there and defend it. That's what we're going to have as like our initialized overworld logic. So what we're going to do is we are going to create a new class, and I'm going to go ahead and put this in a folder, and we should start doing that pretty much with everything from here on out. And I'm going to, first of all, realize that I am in the incorrect directory. We're going to go to custom, we're going to go here and create a new folder, and we're going to call this city. Cities? We'll just call it city. And we're going to go ahead and create a new blueprint, and it's going to be an actor because we want it visually represented in 3D space. And we are going to call this BP City. It's going to be an actor. And I do that all the time. When I actually type that name there, that was searching. I wasn't actually typing the name. Now I actually typed in the name. I do that almost every time I create a blueprint. But anyways, we'll go in here. We're going to go add a static mesh for a city. Mesh. Static. The difference between a static mesh and a skeletal mesh is that a static mesh is not rigged to a skeleton, meaning it doesn't like bend and move and stuff like that with regards to animations. It just stays there. So like a house or a city is a good use of a static mesh, although there are reasons you can even make them skeletal meshes if you want. Cities are going to be, what kind of shapes do we have here? We got a pipe. We got a torus. We'll make a city a torus, okay? So cities are a torus. Now, I want to have a little bit of scale for this. I'm just going to drag one of these cities in here. That is way too small for a city. So we're going to go up here, and we're going to crank this up. Now, I will say, I highly recommend never doing what I'm about to do, which is adjusting the scale directly through here. I recommend having all your meshes perfectly scaled via importing and adjusting them every single time. Now, obviously, that's an ideal situation. That takes a large amount of time, and no one's ever going to do it, including myself when it gets down to it. If I ever do need to make a change, that's going to say, bah, screw it. I'm not going to edit the mesh. But that's the way you should do it. You should only do this really as a last resort, but we're going to do it for right now. So that's a city. This looks good. We need to be able to have a way to change the color of it. So what we're going to do is we're going to copy the code that's already in default to change the mesh of our color for the players, and we're going to put it in a new material that's going to be specifically for the city. In fact, we'll probably use that material for a whole bunch of things. So we're going to go back into our custom. I'm going to go ahead and say new. I'm going to call this faction, and we're going to put all this stuff in here. Move here. And everything gets associated automatically. So anything that references stuff in directories automatically gets updated. So we don't have to change any of our code, unlike if this was C++. One of the benefits of this, although there are many downsides to it as well. But I digress. We will continue on. We're in our factions. We're going to go to materials. We're going to create a new material. And we're going to call this faction. We're going to say im faction. We're going to go here. We're going to look at a UE form mannequin. We're going to select this here. We're going to copy it. We're going to paste it here. And we're just going to do this. And that's what we're going to do. I don't know why this default value is 0. I feel like this... I mean, clearly this has to get overridden, or literally our character would be invisible, in my opinion, unless translucency is off. which might be the case. I mean, it might be. Anyways, what I'm going to do is I'm going to go to our top-down character, and we're not going to be using this mesh at the end of the day. So we're not going to care about the detailed texture that we see, like all these joints, and we're just going to replace it with our faction material, which will cause him to re-update once these shaders are compiled. Any moment now. Anyways, what we're going to do is we're going to be doing this, which means we do have to change some of our code. Wait, no, we don't. We don't have to change any of our code because it's still called body color. Yeah, we're good because we're looking at that there. We're creating a material instance. The material instance is dynamically created, so we're good. We will then go to our city. We're also going to create a dynamic material instance. And we're going to make... Oh, I have to change this, though. Oh, I am looking at the wrong thing. I need to go to our character, and we need to look at the... Our character is not... We don't have... We lost our character. Never mind, we didn't. Tab's way over there. I just missed it. All right, what we need to do is we need to go into our construction script, and we need to make sure that we update this to say faction. The construction script is actually overriding it, which is why we weren't updating it. So that's what our character looks like now. It's just nothing. It's a really basic material. We don't have any concern for UVs. We're just coloring everything the exact same. We are going to do the same thing for our cities, which I should just probably have copied this. Go over to this here. Actually, we're fine. We're already set up. And faction. Promote to variable, and we will call this faction color material instance. And the reason why it's got to be an instance is because it tries to share a lot of the properties between shared components. So if you spawn like 3 actors of the same type, and you change one material, or the color of one material, it'll actually change the color for all of them because it's pulling that data from the material. They'll all share it. However, we don't want that to happen. We don't want to have it when we color our Purpulons purple that our Redivians become purple as well. So we have to create their own material instance. So when we edit their material, it doesn't affect everyone else. And that's the reason why we're doing it. So we got our faction. We have our faction color material instance, and then we save it there, which means that we can then update this whenever we need to, which it's not going to be off of default. It's not going to be off of event gameplay. It's going to be off of a game event. In this case, what we're going to do is we're going to go ahead and say we're going to have a new function, and we're just going to call this claim. And we're going to go ahead and do a variable here called claimed, or is claimed, to let us know if this is already claimed. The default value will start at false, and we will go here and claimed. We'll say branch. If we are trying to claim but it is already claimed, print string. Yo, dog. That shit is already claimed. We'll print out that message. But if it is not claimed, first thing we will do is we will set it to claimed. We will then we will do something very basic for right now. We're just going to go ahead and say just pass us the color. This is going to be kind of like a hacky way to do this. I wouldn't do this, but the way that I would like to do it requires us to do a few steps that are going to be a little bit convoluted and probably a little bit too much for the level of this tutorial. So for what we're going to do is we're just going to have it just pass in the direct color, which will pull directly from the mesh, the color that we're using from the mesh, because they're the exact same color. We then go ahead and say get our faction color material instance. We will then say set scalar parameter value. We will then say body color, even though it should not be called body color at this point because this is not a body anymore. Although you could argue that it is a body. A body is anything that kind of takes up volume. So maybe not. I did scalar parameter again. I apologize. Set parameter vector parameter. And then we will pop in this here, doing the auto convert. Set this to is claimed, and then the color will change. However, we need some logic to have that happen. So what we're going to do is we're going to add some collision to this, and we're going to add a sphere collision. We're going to make sure that it is rooted to the base root, not the mesh, for reasons that are hard to explain at this point, but I would recommend having this here. We are then going to scale this up. Actually, we're not going to scale this up. We're going to make it bigger, but we're not going to scale it up. And that might be confusing. The reason why is because we're actually not going to change anything about its scaling, but there is a value here called sphere radius, and you absolutely want to use this over any other scaling whenever you can. I'm going to change this to 500, a little bit too big, 400, 300. 300 looks fine. You know what? I'm okay with 300. We can kind of see. Looks pretty decent there. Now what this is going to do, it's going to make it so whenever something overlaps this, we can then generate an overlap event. And then we can then say on begin overlap. If we click this here, it'll actually create logic for us. It was actually supposed to take us here. Like it was actually supposed to take us here when I clicked it. It was a bug that it didn't, but it's fine. I know what I was supposed to do, and now that we're here, this is a logic of anytime something overlaps this execution pin is going to fire, and it's going to pass out information with us. And what we're going to do is we're going to say, okay, if we overlap this with this, we're going to say, hey, first of all, did we overlap an actor? You don't have to do it this way, but this is a way that's a little bit more direct in understanding. You can actually go there are many different ways to do what I'm about to do, but this is the one that kind of explains the most directly. And the first thing we're doing is saying, is the thing that collided with us an actor? If so, get its class, and see if its class is of the same type of top-down character. Meaning that if it's a top-down character, meaning if it's me or any of the enemy factions, then we claim it. However, we don't have to worry too much about this being spammed because we kind of have this already. Or we have the logic to make it so it can only get claimed once. So right now there's no way to unclaim currently, but there is a way to claim. But there is one problem here, is that we need to pop in this color. So what we do is we take in the other actor, we say cast to top-down character, and we're going to plug this in here. And actually, I'm actually going to show you. So this is a bit redundant. In fact, you could actually just use this. This is one of the alternatives, and you wouldn't need this here. And you could use the false pin as the false here. It would be almost identical. But like I said, this is not quite the same. So instead, I'm going to keep both of these in here to keep it a little bit more direct of what we're doing. So what we're saying is that, okay, we're then going to say, well, at this point, we know this is absolutely going to be a top-down character because we know it's of the top-down character class. So we cast it to top-down character, and just like with C, C++, anything that's like object-oriented, what casting allows us to do between one object class and another object class is that it will then let us get any of the functions dynamically that are part of it. So when we go down to top-down character, we can say, hey, get the mesh. And then get, actually, no, I'm sorry, not even that. We want to get the material instance, get material instance, get scalar, get vector parameter value of body color, and then set that to the color that we are using to claim. I don't know what this... What is that? Okay, that's what I want. I actually do want that. I've never seen something like that before. So we have a boolean here to allow us to have a single parameter on that node. That's a bit unusual. But but anyways, what we have now is a system that we can now claim these cities. That meaning that it'll be the color. And it looks like we might have messed up. But that's fine. UE4 makes this very easy for us to debug. Actually, it is claiming. We can see that we are claiming the city. That's what that wire... Actually, it's going to be hard to see. Unfortunately, I have two monitors. But as I go out of it and I hit it, the logic is being called. Something is happening. Oh, I'm a fool. I'm a fool. It's working, but it's already the color that I am. Yeah, so that's an issue. We will go ahead and make our default character color something different. Or no, what? We'll make the city have a default character color. We will go ahead and say, we're gonna have to do in our construction script then. We are going to keep doing scalar. I don't know why I keep doing set vector parameter value. We're just going to hard code a color in here by clicking this wheel. We will make it so these start out as yellow. We currently have nothing that is yellow. Or orange. You know what? Orange is kind of like a good, like, hey, this is kind of inactive. It's not destroyed, but no one's really an unutilized color. That's what I'll call it. We will then use the value of body color, and because this is on the construction script, if we click compile here, it'll affect it immediately, and then when we click play here, we still are not claiming it. All right, so that means that we are calling the logic, but the claim is failing. So we'll go to our claim, is claimed, which should be false, set to true, set scalar parameter value to the value here. You know what we're going to do? We're going to do this. I'm concerned about that Boolean, so we're just going to make it so we only have to convert once. Oh, there's our issue. Gotta set the value here. Body color. There we go. That's actually what the issue is. But anyways, because we made that change there, we also have to go to our event graph of this here. Write that there. Plug that in there. Compile. And then, huzzah, we are now claiming it. Now, if anyone paths into this, they'll get it. And I guess we can go ahead and test that out. We'll make it a little bit easier by go ahead and deleting some stuff here. They seem to always spawn down here. There's some sort of logic that I'm forgetting that I messed up that I need to fix. So they spawn like everywhere. Top down, custom city. We'll put another city like over here. And then like one over here. And then also what we're going to do is we're going to go down to our top-down character. We're going to go to our event graph. And this range here, we're going to crank this up. Let's make it 2,000. They're going to go pretty far. And now they will go out and try to claim cities. Ooh, so close. He was close. Oh! The blue one stole it just right before him. And as you can see, I can't claim these. And if you see the prints right here, it says, yo, dog, that shit's already claimed. So we cannot claim these. These have been claimed. But this one over here hasn't been claimed. It's currently the unused color. So if I claim it, I now have the city. Also, I'm going to go ahead and rebuild the lighting so these squares go away, because that's what they're doing. They're staying there because the lighting hasn't been rebuilt. Also, we have a message log, which means that we probably have a null pointer error. Huh. Why is this saying that's giving an error when it's working? Oh, it's pending kill. That's fine. Also, why isn't it doing for every single one? 1, 2, 3, 4. Maybe they're spawning outside the bounds and they're like getting deleted. That's what's happening. They're spawning outside the bounds and getting deleted. 1, 2. So I might have 2 instances of the errors now. No, I had no instances of the errors. Wait, what the? Also, we're gonna go ahead and get this so we fix it so this all gets spawned appropriately because we're doing something wrong here. Negative x, negative y, blah blah blah. Make vector. But it's always going like negative x and negative y. Is it because of something like this? Why do they always spawn down here? It's always like they're getting negative values. If I put these to 0, 0, they should be spawning at the top right, right? Yeah, so, wait. What is going on? This is more of what I want, like, although yeah. Why is this working? Clearly. Oh, that's right. I'm a fool. It's a box. I'm sorry. It's a box where this is the origin, meaning it's the center of the box. And these are the extents, meaning the ranges outside of it. I am a fool. I have a question from Nolath. What do you say one should start with in creating a game? The modeling or creating some sort of important system? I would recommend ultimately what you want to do is you want to create all your assets last. That's in a perfect world. The reason why is because there's a lot of stuff that you have to do through programming that will either A, put limitations on the assets that you need to create, the way that they need to be created, maybe the way that they need to be rigged, maybe the way that the materials are set up. Those could be huge, huge things. And if you create all the assets first and then you get to that point, that means you need to go up back and edit all your assets. However, that's a perfect world. That generally doesn't happen. Usually what happens is you get to that point in time where you're like, oh, we do want to make this change. Crap, we didn't think about this beforehand. Let's build a system to support it. So that's generally what usually happens. And what you can do to kind of not have that problem is try to plan out everything you can beforehand. However, I will tell you, every single game is always drastically different when it's finished than when it's initially conceived, except for like games that are made like game jams, like miniature games. I'm talking about any proper game that's released. It never meets its final designs. It's always held back by limitations. It's somehow not at its full potential because things had to be done. So you definitely want to make sure that if you are going to be doing something like that, that you plan out as much as you can beforehand. I would definitely say it's way better to create your assets last. I can think of some great examples. Is that there was a game I was working for, and they programmed like all these like they had an artist. They paid a lot of money for an artist to create all of these skeletal meshes that were rigged to one skeleton. The problem was is that the skeleton didn't have everything that they wanted. Like it didn't have all the finger joints. So what they had to do was they had to go ahead and make a new skeleton, import the mesh, and use retargeting, which you can do in UE4. But even then, retargeting is both tedious, time-consuming, and it's not always perfect. It's always better to create a perfect rigging through the assets themselves. But that was a point in time that where if we knew that we wanted the finger joints beforehand, that we could have done it the first time around and we would have saved a lot of time. But always create the logic first and do the assets later when you can. Now, the reason why I'm doing the logic first and the assets later is more because I'm not an asset creating person. I can create assets, but this is more of a tutorial for programming. So if you're looking how to create assets, unfortunately, you'll probably want to go somewhere else. But I digress. Let's continue on the topic. So we went ahead and fixed the issue. Once again, I want to reiterate of what happened here is I was under the misunderstanding that this was like the left, or this would have been the east, and this would have been the west range. This would have been the north or the south and north range. However, that's not the case. What this is doing is creating a box where you give it an origin, i.e. the center of the box, and then you give it parameters. That you specify for it. So in this case, I'm saying the box is 1,000 units wide, 1,000 units tall, and then actually this is 2,000 units tall. Or no, it's 1,000 units, I believe. 500 units in both directions of what this is going to be, perhaps, and then a height of 50. And that gives us the desired results where they spawn randomly around the middle. Somehow I claimed that. Oh, no, I know what happened. They spawned on top of it, and because in that brief moment, they don't have a texture color, that nothing happens. Or they don't have the texture color that's created for them, so they get control over it. That's what's happening there. But anyways, we have a basic system. We can move around. We have some AI. They move around. We can capture cities. They can capture cities. They can't. No one can recapture a city though. But we'll keep watching until this happens. Also, are they going in 45-degree angles? We don't want them moving 45. No, that was not 45. Good. If they are moving at 40, that might have been 45-degree angles. They are moving in 45-degree angles. That means the random logic is doubling up. Wait, was that 45? That's 45. They're all moving 45 degrees. Yep. Okay. So, got another Zangief.
You got paid?
Shout out to Nola. Thank you for the follow. Welcome to the stream. So we had only 3 follows today, and 2 of them are Zangief. There's like 20 of those things. Although Zangief's my favorite. You got paid? Uh-oh. Oh, no. Oh. Whew. Thought we were crashing there for a moment. What was I fixing? What was I going to fix? There was an issue that needed to be fixed with the movement. So that is going to be in our top-down character. So I thought this wasn't going to be initiated, but it is. So if you do want to get it separately, then we just do this, and that will fix it. And now they won't be moving in 45-degree angles. Well, they can still move in 45-degree angles, but now we should see more actual random movement. That was definitely not a 45-degree angle, so we're good there. Why didn't these guys move? Oh, they probably moved because the point that was selected was probably outside the range and not a valid location. That seemed pretty 45 degrees. That's not 45 degrees. That one did. That is definitely not 45 degrees. Okay, everything's looking good here. Okay. Let's do some more things. Let's do some stuff with our cities. Cities need a name, right? Well, UE4's got something easy. We're going to call it it's called a text render. We put that in here, bring it up here, and we will say, this is called city name. Is there anything that we can do? Nah, this is fine. All right, we will make this probably like 10 times the size. We are also going to change its alignment to center. That way we can just design whatever this text is and it'll automatically be centered. Actually, I don't know why it doesn't do that by default. We're going to angle this up just a little bit because that's the way it's going to be. Actually, I don't know. We'll see what it's like by default. Okay. It needs to be rotated around by 180 degrees. We will then rotate it up. And we can actually make it track the camera, but we would need to be able to have references to it. But for right now, this is good. We'll make it a little bit smaller. I think like 7 will probably be fine. We'll call this a city. Okay. And that's how we have our city names. And you'll notice there's like a little bit of odd stuff with like the way, like it's hard to see. Let me maximize this here. But you might see it's like a little bumpy here around here and stuff. That's the temporal AA, the anti-aliasing that's by default, and also its mixture of the resolution of it. Anytime that you take a text render and you scale it up, or which and you scale it up, you're going to lose a little bit of resolution, and you can adjust that through several different ways. One of the ways is creating it overlarged and then shrinking it down. Another way is to adjust the actual text itself to be higher resolution than the ones that you select through here. But for right now, we're not going to worry about this. We're going to claim it, blah, blah, blah. So we have cities that can be claimed. Let's make it so that our cities are randomly spawned, just like our players, because ultimately that's what we want to have happen. We want it so whenever the world is created, that we can then spawn cities. And we're going to keep some of this terrain around. The reason why is because we want to make sure that we have logic where it's not going to spawn in terrain, the cities. And UE4 handles that for us naturally. Okay. So what we're going to do is we're going to take our overworld, and we're going to do something very much similar like this, where we're going to create a new class called City Manager. So custom city blueprint, and we're going to make it an actor again because this is going to be spawning actors. So actor spawns actors, objects can, but they need a reference to world context, which makes it a little bit harder. So we go over here, we'll specify actor, click OK, call it BP City Manager. We will then go to our overworld game mode, and then we will go ahead and say spawn actor class. Excuse me. And just so this gets organized, we're going to do a sequence here. Now, all this does is programmatically is makes it so there's an order in which these occur. There's no difference than if we were to keep it using the execution pins at the end. This is just purely for layout purposes within Blueprint. It does nothing whatsoever actually to the code. I mean, there's no difference. There's no difference between this and then having this without the sequence. Ultimately, there's literally no difference between the code. This just doing this for a little bit of clarity. Put that in here. Spawn it at 0, 0. We will spawn in City Manager. I'll try to keep these somewhat similar. And then we're also going to do initialization function on this one as well. Going to function initialize compile overworld faction. Nope, top down. We will wait. Where are we going? I'm just going all over the place. Overworld is what we want, and then we go ahead and call our initialize function. And either we didn't name it right or we didn't save. We didn't name it right. Go ahead and name that the proper name. Go ahead and click compile. And then we will go to overworld again. Sorry, just a little bit lost there. I'm going to call this initialize. And actually what I'm probably going to do, I probably won't do it now, but later I'm going to rename these initialize to be like City Manager initialize and Faction Manager initialize. But for right now, this is fine. We go here, we go to initialize. We'll go ahead and I'm going to add some variables here that we will adjust procedurally at runtime, but we can still use them for right now with hard-coded values. And I'm going to call this max cities. And this is just the max number of cities that we can have. I'm going to put this at 5. And what we're going to do is we're going to say, we're going to have another, actually, we're going to have we're going to have a Boolean here. We're going to say, wait, we're going to do max attempts as well. Also going to be an integer. Max cities, max attempts, compile. We will say 50 attempts. Why did I make this instance editable? All right, we're going to say for each loop. And then we're also going to create one more variable, and we're going to call this cities. And we are going to make this an instance of BP city. And then we're going to do something here where we click this button right next to the variable type. And we're going to select these squares. And what this does is it makes it an array of this type. So now we have an array of it, or kind of like a list in C++. I mean, you can still use arrays, but or C sharp. If you're using C sharp, it'll be more like a list of instances. But we now have a list of all of our cities and stuff like that. What we're going to do here is we're going to go for in our initialize, get our max attempts, and we're going to do for loop with break, and we're going to say do this 50 times, at least 50 times. Or no, I'm sorry, do this no more than 50 times. We are going to run it. We may not run it 50 times because we can always break it by running an execution pin here, but we're going to check anyways. And we're going to add another one. Actually, we don't need anything there. We're good. So what we're going to do is we're going to say for max attempts, get the current length of cities that we have. If the length of cities is less than max cities, that means that we can still spawn a city. However, if not, we've hit the max. And then what we want to do is break our logic because we're done. Why keep processing when we've already hit our max? Okay, simple enough, right? So for each of these attempts, so we'll do this up to 50 times, we're going to see if we have 5 cities spawned that's in this array. And if so, or if not, then we'll continue on this logic. But if there are 5, or if there is not less than 5, I'm sorry, there is less than, I'm sorry, no, I'm getting this all mixed around the way this should be properly worded. Let us do this 1 second. We got a question from Noah that says, why did you choose the Unreal Engine? It's free. It's free, it's capable, it has everything that you need to do from it. It gives you the robust capabilities of being able to do a lot with an individual developer. I feel it's more powerful than Unity. It gives you, it's all open source. It's all open source. That's like, that right there. It's all open source. Should be like the only reason that you need. That and it's capable. It's capable and it's open source. All other engines that are capable, very rarely will they be open source. So yeah, I would say that's really the big thing. Entire engine source code is open source. If you want to make a change to the engine, you can do so yourself. If there is a bug in the engine and you want to fix it, you can do so yourself. And that's why I like UE4. However, a lot of engines have benefits. UE4 is not the only engine. I recommend everyone try out whatever engines you feel comfortable with. However, UE4 is free. It's easily accessible. I do highly recommend it. And also the blueprint scripting like here is very easy and efficient for people that are getting new to it, which is why I use it as the medium for my tutorial series, because it's very boring. Just watch someone typing all day in C++. I've tried doing that. No one watches those videos. People prefer blueprints. Hands down. I get literally over 100 times the views times a magnitude of 10 difference. I think that's right. Magnitude's 10. 10 times 10 is 100. I'm right? Am I dumb? Someone double check my math because I'm too lazy. But anyways, I'm not really saying like one engine is better than the other. I mean, just use whatever you're good with. Ultimately, at the end of the day, if you're looking to make a game, you need to make that game. If the engine can do that, your problem solved. Just do it. So we're going through max attempts. We're checking to see if this here. If we are not, then what we are going to do is then we are going to get random. I guess we do wanted to make sure it's what's the difference between location reachable from the given origin location. Navigate space within the given radius of the origin. Okay. So we do want some place that's navigatable, because if they can't navigate to the city, how are they going to get there? So we're going to make sure that we do that. What do we have to do here? Filter class, nav data. Oh, we got to do this here. I can't remember if blueprint level logic processes before game mode. I'm pretty certain game mode logic happens first, but the problem is I need to create the nav data. But I'm not sure if the nav data is going to be accessible at this point that's early on, which means we're going to have a race condition. This is going to be training a null point error. I need to have a way to give access to it. I have a question from Working. By the way, how hard is making a character movement based on tiles, similar to Game Boy Pokemon games? Very simple. It's very, very simple. In fact, that was the last thing that we did. We did a tile-based movement system in the last tutorial stream. Unfortunately, it is not recorded, so I cannot link it to you. But what you would do is that here, I'm gonna have to bring out an MS Paint for this. I'm gonna have to cut this out of the video. So you have a tile-based system, okay? So you have this is your screen, and then pardon my we'll make this a very this is a very basic game, okay, everyone? This is a very basic game. This game has a total of 9 tiles. It's a very boring game. This is tic-tac-toe. But we want to be able to move in between these. It's also assume this is a perfect square, okay? Like a lot of imagination is needed here, guys. This is MS Paint. So what you do is there's 2 things that you need to keep in mind. Is you need to keep an index of all of this. So in this case, this right here is its vector is going to be 0, 0. And the one down here is going to be 0, 1, 2, 2. Is what we have, right? That's what we're seeing. And the reason why we want these is because that's where we spawn the tile. We say, okay, get the tile, and then spawn it at these coordinates. But you also need to add the width of the tile. So you'll usually have a variable somewhere, and the variable will be tile width equals 30, something like that, right? I mean, you'll do like unsigned int 16, 32. We'll just do unsigned int 32. Tiled width equals 30. And then basically what you do is you just have your logic do across that. So then you code your tile logic to just draw whatever data is in there into the screen buffer, and then you move over the index, and then you get the next ID of the tile that you want, and then you know exactly where to do it to, and you know how far you need to draw it to. That also means that if you ever want to upscale or anything, you can have a variable that you multiply against this, like a multiplier for like aspect ratio scaling, or you can literally just set it directly. And so that's how you get the tiles, but that doesn't get you how the movement though, because that's not going to work about the movement. The problem with that is that you can't move one index at a time because you'll just instantly teleport. You want to move smoothly across from it. So what you'll do is you'll have your position independent from the index system of the tiles, where you'll just keep moving. You'll just move across. It doesn't matter, because it doesn't matter where you are in these tiles. You're still doing hitbox collision. You're only doing the tile system for the background. However, I will say that if you want to do that in UE4, if you're looking for a solution that is specific to UE4, then UE4 has got you covered. If you go into their plugin, you will find something called Paper 2D, which is actually on by default. And it has both a tile system built into it, a 2D tile system built into it, but also a 2D flipbook system. So if you have, hand-drawn sprites, you draw on multiple sprites, or if you've created your sprites and you want to animate them together, you can do all of that in UE4. You do not need a third-party program to do that. You can do it all within there with the Paper 2D. So those are some ways that you can do it natively with UE4. But like I said, if you're not using UE4, you want to program it all directly, I deleted it all, but I lost it all. Anyways, if you look at the document that I kind of made a little bit, you can understand the hastily scribbled MS Paint, then that's all you got to do, and you're good to go. Not a hard system, very basic, very, very lightweight. In fact, I would say honestly at this point, unless you're programming for like microcontrollers, very, very small stuff, even if you're programming for mobile devices, I would recommend foregoing a tile-based system. It's really not worth it. I really would recommend using a complete background for whatever background you want. Don't use tiles. The reason tiles were used is because there was limited space in memory. And here, I'll explain this as well. This probably needs an explanation. So back in the day, we had limitations in memory. So what you would do is you'd create a single tile sheet that had all of your textures essentially on it, all the unique designs that you would have in a 2D game. And the reason why is because if you have, like, let's do a ladder. A ladder is a very basic thing that this is a good example for. You have a ladder, right? And we're going to try to tileize this. And you want to have it so it's a long ladder. It goes all the way from the top and the bottom of the screen. Now, the way that I would recommend doing it in modern games is to do something like this, create the entire ladder, and then export this entire ladder. The reason why is because this ladder, what is this? This is going to be a 100 by 431. This is nothing. Even on mobile devices, this is nothing. This will run on the worst mobile device that can run UE4 projects on it. But back in the day, this would have been overkill. This would have took up a lot of necessary needed space. So what they did is they did the tile system, where what they would do is they would only have this segment stored in memory, and only this. And then when they were drawing the screen buffer, the data that determines what's going to be on the screen, they would say, okay, when we're at this index, draw a new tile, a new instance of it, but it's still pointing to the original data. And so it's creating instances of the same memory, or the data that's in the same memory address, and it's doing it over and over and over again. And so even though it looks like it's one complete ladder, it's separate tiles. It's a bunch of different tiles. But like I said, tile systems are outdated. Memory is abundant. Mostly what you're limited by now is GPU, which isn't going to be a huge big issue. I would recommend creating your background all of it at once. Even if you want a tile aesthetic, create it all. Just create the full tile in an asset editor and then import it in and just make that your background image. If you want collision, build your collision around it. That's one thing you do kind of get of a benefit of a tile system, is that say if you do have a tile system and you have a wall, something that you know is a wall, it'll always 100% be a wall. A player can never bypass it. You can have it whenever you draw that tile that you also add in the collision logic dynamically. If you don't do it that way, if you do it the way that I recommend, the alternative is that you have to then hand do all your collision on top of that background. So if there's a house there, you don't want them to be able to walk into the wall of the house, you got to say, okay, this is an area where they cannot move through. If you do that in UE4, it all handles it for you. But even if you don't do any UE4, that's a basic task. One of the most basic things on video games is if something overlaps something. If I overlap that item, I pick up the gun. If I'm near a door and I press X, that means I'm near the door. It determines I'm near the door by overlapping some sort of collision with a door. And so like, oh, you're near a door. And if you hit X, you're going to open up something. And which door we're going to be opening is the door that's colliding with our collision. That's how we know which door specifically to open. So there's stuff like that that we can do. But anyways, we're going to continue on to our city manager. We have it, so we're checking to see if there's at least 5 cities. If we don't get this within 50 attempts, we stop. But we're going to continue here. We need to get this nav data, and I'm trying to remember the ideal way to do this. Can I just do get nav? Oh. What the heck is this? I'm going to have to look through this real quick. Oh, by the way, you can get passing costs already, too. This is dope. One of my favorite things that you can do. The navigation system is really neat. If you need to program any sort of pathing, you really shouldn't do it yourself in UE4. In fact, almost every engine will have pathing logic for you. You should never really program it yourself. Don't reinvent the wheel. That's very difficult to do. Navigation. Wait, what? 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 I'm a little confused there. We got a question from looking. Oh, right, but I'm looking into implement the type of movement into a 3D project. Would apply the same logic? Yeah, even in 3D, it would be the exact same thing. Even if you wanted to do a tile-based system, it would still be the exact same thing. The only difference is that in a 3D-based system, your 2D assets become meshes, so your tiles become, rectangles, um, and all your logic has to be dealing with that extra dimension, your z dimension or your y dimension, depending on whatever crazy, you know, engines that you use that have y up. But yeah, the exact same principles that are saying. You're still using collision logic. You're still doing detection. If you do a tile-based system, you're still saving memory because you're pulling it from a single thing in memory rather than having a huge giant mesh. However, I will say this: if you do a tile system, what you're gonna have to do is in UE4 you're gonna have to spawn a static mesh, which means you're also gonna have to spawn a material, and that becomes expensive. Which is why I would not recommend doing a tile-based mesh, a mesh slash a mesh and tile-based system in UE4, just because every single mesh that is a tile will also need its own material. It doesn't have to be the instance of the material, but it will need its own material element, which does add up. It's a lot of things. It's better to have all your landmass have one material element or three material elements rather than having every single tile of 3D space have its own data for that. Now, if you're building Minecraft, you have to do stuff like that. And what you do is you just do a vector system, which just means that you have an origin, you do the offset just like the tile, and then you just have properties associated with that origin, and you can't double up on that origin. There can't be two blocks in the same area. That's all vector means, by the way. Oh! We got a follower here. We got Lurking by the Way with the OG Dio with the Re. You know what? I created that one like 5 years ago, well before like Stardust Crusaders got big and everything. It's from the OG fighter, the fighting game JoJo's Bizarre Adventure. I forgot about that one. I'd probably need to update that one just because everyone's like into JoJo now. Although I am not a fan of JoJo, I gotta say. So, you know what? We'll take a look at this later. For right now, we're not gonna have problems with navigation because we're kind of doing logic that's going to be handling anyways. So we're just to do it a way that I know right now, and then later I will do some looking offline to get the better way that we need to do it. But just to explain is the issue that I'm having right now is I'm forgetting how we can generate the nav mesh and then store that data in a way that will be accessible immediately for the game world object, because I'm uncertain if the level blueprint will process at this point in time, which is the event begin play of the game mode. So I'll take a look at that later. We're not going to deal with it now, but you know what? Not an issue. We got plenty of things that we can do to get the exact same functionality. So we're going to go back to our city manager. We're going to start moving all of our classes over here. One moment, just going to take a sip. We're going to do the same thing that we did there. We're just going to get a random bounding box using our origin as the world location. We're going to say, I don't know what the size of our map is. We'll just do 5,000 by 5,000. It's probably way too big. With a height of just like 10. The height's not really a matter. It's just more, if I ever want to visualize this, it'll be easier to see. We go out here. We will say spawn actor from class. And we will say try to adjust location. Do not spawn if still colliding. And we will get, say, make transform. Once again, we're going off of the origin. This will probably be updated later, but we're just going to go ahead and pop this bad boy in there. Actually, we're going to go pull this out and we're going to say make. And then we're going to break. The reason why is we don't want the z value. We want it to be at 0. And also, I'm going to do something real quick. In our BP city, I actually want to go here, take this here, and because this is what counts as our collision, I just want to make sure that it's not going below 0. No, it is good. In that case, what I'm going to do is I'm going to make this, or the z value here, I'm just going to make it like 2, just to make sure we don't have any issues with this getting hit. BP city is the thing that we want to spawn, and if the city is valid, meaning that we did spawn a city, meaning that we didn't get caught by our condition check here, that we then add it to this here. And then that stops the logic for this instance. So then we go back to our loop, and then we do this again. So basically, we get 50 attempts to try to spawn 5 cities. If we don't get it within 50 attempts, we stop. However, if we do spawn 5 cities, we just stop right there. We don't need to process the logic anymore. Very basic stuff, nothing too complex. Does it work? That is the question. So we are going to try this out. My guess is that cities will spawn. If not, that it's probably this right here. I might have to adjust the z value higher. And I'm also guessing cities will spawn outside of the bounds. So let's take a look. Did any cities spawn? I am not seeing any cities. Are you? Is anyone seeing any cities? I don't think so. So I think something went wrong there. But we're going to double check. We're going to go here. I forgot to generate the nav mesh. I can tell already. Actually, that's my. Actually, no, that's not a problem because we're not using the nav mesh for this. Oh wait, I didn't want to stop there. What I want to do is I want to tab out here, and we're just going to see if these cities do exist. They do exist, so they're in there. They're just not being spawned in the correct location. So what we're going to do is we're actually going to do this in our pie, which means play in editor, which means this means screen right here. The reason why we're going to do that is because if we hit F8 here, we pop out of possession, and we can take a look around. Oh, wait. Okay, so our cities are spawning. They're just way out there, kind of like I guessed. And they're not spawning close to us because they are definitely colliding with this here, because the height of this is not at 0. So what we need to do is we need to go here, and we need to make sure this... We don't know what the height of this is, but we're just going to make it so we're kind of at 0. Where is this at? We'll make... That's 0? All right, so that's 0, where this guy is. Okay, bring you up here, save. Also, you see these guys fall now because of it. Am I still possessing? Oh, I need to rebuild the mesh data. That's not what I wanted to do. That's not what I wanted to do. Mesh data, please? Or nav mesh data? Rebuild nav. Show apply navigation. 1 moment. UE4 rebuild nav mesh. 1 moment. I gotta remember how to do this. How to make a rebuild nav mesh. That's okay. Well, I don't want to do it at runtime. Where's build geometry? Okay. Build lighting too. There's should be a button combination you can click, or there should be like a drop down. I can't remember why I cannot remember how. Rebuild Nash manually. Everyone's trying to do it at runtime, which I know how to do. It's so weird. I know how to do it at runtime because that's normally how I do it. People asking for blueprint methods to do it. I know how to do that. Navmesh, basic navigation. Is it Shift P? Is it Shift? Actually, oh, you know what? I think I know what it is. It's this. It's probably our nav mesh bounce. It's probably working. It's just we moved everything down. Our nav mesh didn't get moved down. Yep, that's it. My bad, guys. That's it. Everything was good. Okay, now we can move around. Blah blah blah. Cities are still not spawning in here. I would expect cities to spawn. Pop out. Wait, 1, 2, 3, 4, 5. Well, we did get 5. Let's take a look. Look at these on sideways. Let's see if these do collide. Actually, you know what? Oh. Does that collide? Let's do this real quick. There's a very easy way. All right. It does not look like they're able to spawn in here. Probably because of just the height. We can confirm that real quick by going to our city manager. We're going to up this to about like 20. Play. Nothing. Play. Nothing. We're just seeing if a city spawns near us. Nothing. Let's try 100. And we're just raising the limitations of the city because we do want it to be able to spawn like on ground. There we go. Okay, so that's working. So where does it break at? Let's try 50. We also do have a large range. It just could be that we're getting unlucky. Okay, let's try 80. And actually, you know what we're going to do? We can check this out. I probably know what's causing this. We go to our BP city. We click our torus object, and we go into the torus, and we go to our collision. Let's show simple collision. Let's show complex collision. What are we using here? All right, so this is the actual collision, the simplified collision. So my guess is that's probably, no, that seems pretty good. Shouldn't need more than like 5 or 6 for that to work. That one was a little off edge that spawned in that city. You know what? Also, let's move our camera back a little bit more. I want to get that camera further back so we can see this. Let's do 2,000. Crank that bad boy back. Yeah, that's what I'm talking about. Still no city spawning. Okay, that is odd. It could be due to the fact that this box right here has its own collision that's not an exact cube. I would be really confused if that's the case, but hey, we can confirm that. No, everything's perfect there. There's no problem with that collision. So 50 or 80 is not enough, but 50 is 70. We're going to get one that's spawning here. We're going to take a quick look at it. There we go. Okay. I'm in the wrong. I need to be in pi. Oh, that one's actually real convenient. Is it the sphere? 1 second. No, if it was a sphere, it would be way, way more. Does this have collision? No. Text renders do not have collision. And we also want to say this if nav, what is it? Can affect navigation, yes. And what that means is that when the city spawns in, it'll actually make it so AI know that they can't move there. Even though they couldn't move there, if they did try to move there without that check, they would just constantly run into it. I think there is also a check. Like there is a threshold check where if they don't get to the target within so amount of time, I think it does cancel it. But anyways, we do have a way that we can spawn the seeds here. I'm gonna actually, I should have did this. We're gonna make this a lot less. We're gonna say 2,000. 2,000. So the problem with this is that I think we're not gonna get 5 cities ever. 1, 2, 3, 4. Never mind. We got some cities. Also, I want to make sure there's no collision here, right? All this collision got cleaned up. Yeah. Now mesh knows how to go. We'll claim the city. Oh. Because I'm targeting this. Is there a nav mesh being built on this? No. I need to add some logic so when I click that it doesn't try to do that. But anyways, look at that. Got some people claiming some cities. Also, let's go ahead and delete this top-down template. Text render. We're also going to take this box here. Let's scale it to 50 by 50. All right. So that's pretty good. 2,000 is about the max range of this here. All right, so we got overworld, we got cities. We can make it so we can also spawn some things. 1 second. Let's think about the best way that we can do this. All right, so there's one thing about your game mode is kind of like a global variable system. Everything that's in it can be accessed through pretty much everything within your class, and that can be done through get game mode. However, get game mode is not going to return anything except for the base properties of the game mode, which is most likely not what you want. So you have to do to cast to the game mode instance that we're using, in this case, which is overworld. And then what we're going to do is we're going to say get city. I'm sorry, get city. Wait, oops. We forgot to do something here. In our overworld, because we're going to need these managers that we have, we need to save these as references. So we're going to promote to variable. And this is going to be called our city manager. Wait, no. Faction manager. Promote to variable. And we're going to call this city manager. Just like that. Easy peasy, lemon squeezy. So now, this is, okay, I want to go through this a few times because of all the people that I work with in any programming language, when it comes to object-oriented programming, this is the one thing that they get trouble with, which is pointers and references. How to access. I spawn, okay, so I'm in one class. Let's make an example. I have 2 trees. Very simple. There's 2 trees that exist in my world. There's tree A and tree B. And I mean like actual trees, not like me. Tree A grows fruit, tree B grows fruit, right? 2 different things that exist in the world. Now, what happens if we have a player that goes up and he interacts with a tree? How do we know which tree in the game that we want to interact with? Well, obviously, we can just say, well, whichever one's the closest, but still, in a programmatically aspect of it, how do we actually get that tree? And we get it through references and pointers. And what that means is that we're saying, okay, when we spawn this tree, its data is in a specific address in our memory. What that address is always different. And what I mean by specific is that it's not going to change at runtime unless you do something specifically to change it. But every time you start up the game, that address is most likely going to be different. But the data that's going to be stored there is whatever you have assigned for that variable. HP will have, every variable you have will have a memory address associated with it, which is very important because all you have to do is when you spawn a tree in a programming level is you just say, okay, this tree is stored in this memory address. This memory address is stored in this variable. Literally, the address of that memory is stored in a variable. You now got the concept of pointers, essentially. So what we're doing is we're saying, okay, here is the memory address of the closest tree via that variable that stores the address. We then pass the variable address of the tree, and then we affect the data there. So if we need to change something with the tree, we change the data that's at that address, and we have now affected only the one tree that we wanted to. So if we harvest the tree, we harvest its fruit. We don't harvest the fruit from the other tree. Or if we harvest a tree, we just don't get the first tree that we spawned. That right there is probably one of the most hardest concepts to get. Shout out to Games UK Studio with Civ 5 Baba Yetu. Although I think that's the Civ 2 globe. I think it's officially the Civ 2 globe, but the song is Baba Yetu, which is from Civ 5, which is also the only video game song to win a Grammy. The only video game song. Very good song. It's the Lord's Prayer in Swahili. Baba Yetu Tulie Bingu Yet Ten Tonami. Can't remember how it goes. I don't speak Swahili, but it's a very good song. One of my favorite parts of launching that game was hearing that song. But anyways, back to programming. We are here, and we got our faction manager and our Syndion manager set up, and we're saving the references to them. And the reason why is because if we ever want to access this faction manager that we spawned in dynamically at runtime, all we have to do is go to our game mode, cast it to overworld, and then get our faction manager. And then we can do everything that our faction manager can do through here, through this reference. And that is a really hard thing to get. And if you don't understand what I just said, that's fine. I'm not the best at explaining it, but this is a hard concept. Understanding like how memory addresses are used, understanding instantiations of the same class, meaning that, you know, if you have one NPC, but they all look the same, that probably means they're all from the same class. You just instantiated X amount of copies of them. Understanding that, understanding why we do that and how we do that will help you understand of like why we do these references and why we have to like save references, and also explains null pointer errors, which are probably the most common runtime errors that you experience. You've probably seen it before. It's like null pointer. What that means is that, say if I do this, now this is the problem with the system with object-oriented programming and doing these systems, is that there's nothing in the world that guarantees that this is valid, that what comes out of here is valid. Nothing also guarantees that what comes out of here is valid because this is generated off of that. And the reason why is because we have to cast stuff. And that becomes a problem, is that you have to make sure that you cast things of the appropriate type, because you can cast anything to anything. This faction manager, let's cast it to, well, I can't cast everything to anything because it's inherited. Let's go to something a little bit more basic. Actually, never mind. I can. I can do cast to, it's got to be a class though. Class to avatar. I'm sorry. I'm thinking of a different project. Character. There's nothing saying that you can't cast this. It'll never work, but there's nothing saying that you can't cast this. So as a programmer, you have to make sure that when you write this code that this will work, that what is being fed into it will always return a valid output, because if it doesn't, you get a null pointer error. The infamous null pointer error. And it usually happens with race conditions, or stuff gets deleted unexpectedly, or you move to a state where you can't get deleted. And I will give a great example of that actually affected a huge service. In the Burning Crusade of World of Warcraft, the second expansion, there was a bug where you could crash the entire server very, very easily, and it was because of a single null pointer error. And the reason why that was is because if you created an arena team, it would create a record of that arena team that would be associated with an ID. And then there was a function that said, okay, if you pass up the ID of an arena team, we're going to get you the properties of it. We know that for certain because we have all the data. The only time this function can get called is whenever the data's gone. In fact, we even make sure that if the faction, the team doesn't exist, that they don't have the prompt. They did all that. There was one tiny mistake, though. What happens if someone created a team, invited someone to that team, disbanded the team before that person accepts joining the team, but then clicks accept. What happens is when that player gets a prompt, they then cache the ID of that team. And when they click accept, it'll then try to process the ID. However, the system was built that, oh, everything was built normally. There has to be an ID there. However, the cached ID doesn't point to anything anymore because they deleted it. They deleted it before the person accepts the team invite, but because the ID is there, when they click accept, it crashes the entire server because it finds no team because the players deleted the team that they invited them to, but the state system wasn't updated. That is a null pointer error, and it's one of the most common causes of crashing at runtime. You'll see errors on Blot again pop up that says null pointer or could not access memory value, stuff like that, meaning that the memory that or the data that we expected to be at the memory address was not the data that we expected to be at the memory address. So keep that in mind. If you don't understand it, that's fine. This is probably the most complicated thing people have trouble grasping when it comes to object-oriented programming. You're not alone. You'll get it. You'll get it. Just hang in there. But anyways, I actually do need this logic, but we don't need a faction manager. We're going to head and say get city manager. And now we can access our city manager along with any functions that we want to do in our city manager. However, right now, there isn't too much to do, but we can get some data. We are going to get our cities, or an array of all the cities that we have spawned. And what we're going to do now is we're going to say, okay, for each city, is the city claimed? If the city is not claimed, you know what we're going to do? We're going to try to move to that city. So if we're not there, we're going to go ahead and say get actor transform, simple move to location. Can I just pop this in here? Didn't think so. Every time they do an update, I always hope that they'll just add this in here, but that's fine. We'll break the transform, go ahead and pump in the location, and we will do simple move to location, passing the controller. And this is now our new AI move logic. Still very rudimentary, but what it's going to do is that, we need to put our delay in here. Actually, this is wrong. This needs to be a break. Wait. Break. The reason why is because once we have a success, we need to break so we don't process this logic continuously. Also, what's going to happen is everyone's going to fight for the first city. Like everyone's going to bolt for the first city, and then they're going to be going in the order in which the cities spawn. The reason why is because that's the way that it iterates through this array, and we added them to the array in the order that they spawned. If we wanted to, we could actually get we could pull the length of the array and get a random index and range using the length of the array as the max output of it, then subtract by 1 to get your off by 1 offset, and then you could do it that way to get like a random city, which we'll do eventually, but we won't do it now. But anyways, we will continue on, and then we'll do that. We'll break there. We'll complete down here, which will then add a delay for 5 seconds, and then we pop back here, and we do it all again. But the question, as always, gentlemen, is does it work? There's only one way to find out. We will play. It does not work. We're going to go ahead and take a look here, and we're going to see what's actually happening. So we're at the delay. It's processing the logic. I am a fool. I did something very, very basic. I see exactly what is the issue, and we will rectify it. The problem is that we are checking our logic whenever the city is claimed. However, no cities are going to be claimed by default. I used the wrong value. So we do that there. However, still no success. Wait, what? What was that? What was... But there it is again. It must be with the movement. It must be their decal or something. But anyways, still it's not working. Let's take a look. We will probably see it going successfully through here. But it's probably this that is probably broken. Now, this is the reason why, is that if we pop out of here, hitting F8, is that these locations are probably way up in the air, not really accessible. So what we will do is, did not mean to close that, blah, 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 do. Did I really close the one thing that I wanted? No, I didn't. Here it is. Get that. Make this here. Break this here. And we're just going to pass the X and the Y. We're going to keep the 0 down. And probably still not going to work because, once again, the circles do affect the navigation. And I'm believing that they probably still won't be able to navigate here. Although I can. Let's see. Yeah, it's getting a value. It's just not wanting to actually navigate there. I'm going to make sure this logic still works because I could have broken something when I adjusted like the nav mesh. Let's just double check. Plug this in here. Plug this in here. Plug this in here. Okay. It's because this isn't probably not at 0 anymore. That's why. Alright, but that's good. The fact that this is broken because of that, that means this logic is probably fine, but I need to have it so the navigational mesh is a little bit easier to deal with, but go through here, let's select this here. So this is -20. What if this is actually at 0? Does this start at with a 0? No, 0 is there. So its height is that. We're going to go ahead and we're going to take a look at the mesh. And we're going to take a look at the size of it. I actually didn't even know to go inside of it. You can take a look at the size of it if you just hover over it. It is 100 by 100. So that means that this needs to be going down by -50. And that should mean that this top part is now perfectly 0. Let's double check. We should see them start moving in a few seconds. Nope, still not working. Let's double check our logic to make sure that nothing is messed up there. We're getting valid values. I would say, though, we could having the same issue here, where I need to make sure that we are using the 0 constraint. And no. Oh, that happens whenever I bring my cursor out. It goes to 0, 0. That's what that is. Interesting. We can do, so it's definitely an issue with the navigational mesh being propped. Oh, wait. I did the thing again where I didn't update the nav mesh. Where's the bounds? Here it is. Okay. 500 by 5,500. Does this fix it? Actually, they should be moving immediately. We would see them move right away. I should not have moved the ground down. Move the ground down, all this stuff happens. Also, I'm pretty sure this nav mesh isn't updated. Don't know why. We can go ahead and build the geometry though. We'll just do build. I don't know why it's asking to build the lighting every single time that I just want to build. Just like everything. Oh, it's still even giving me that. It's lighting built. Oh, because the lighting was built last. Why is this nav mesh? Oh, wait, is this the nav mesh? If so, then it's still not set correctly. No, that's light mesh. Navigation, navigational bounds. This is all good. Actually, the nav mesh is set appropriately. That's fine. Yeah, this all looks good with the nav mesh. So why are we having issues? Navigating. I'm going to make sure that we stop spawning the cities for a moment to debug this, to make sure that they are not interfering, just by unhooking that wire. Because we did have the movement logic working not too long ago. I moved the floor down, it does adjust the nav mesh, but since then our simple navigational logic is now busted. And we shouldn't really have too much of a problem even with this now that I think about it, because we are getting this right here, which is our current actor transform. But I will say this will fail on the first one. Wait, is that what it is? Is because they're flying up in the air? What's the height of our capsule component? Capsule component is 96, so half of that is going to be 49? No, 48. Yes, 48. The reason why I need that is because I need to go to our faction manager, initialize. Change this to 48. That should have spawned them exactly at the perfect height. And nothing. How sad and unfortunate. Let's make sure that our player controllers are still being set. Set vector player, possess. Yes, create AI controller. You're possessing it. Using the exact same location that we're spawning it at. Blah, blah, blah. Possess. Hmm. 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 Ah. Hmm. Ooh. Oh. What could be causing this issue? Is NPC. We spawn these as NPCs. Let's just double check that. Faction, overworld, initialize. It is an NPC. We're spawning it there. Getting a random within that range. 48, because that's 48 is half the height of the capsule component. Let's just make it, you know what? Let's just make it a nice 50. Spawn him above, make sure he's not stuck in the ground or something. The nav mesh is all built. Geometry is all built. But they don't want to navigate anymore. So at some point within the past 15 minutes, we broke this logic and we don't even know how. How unfortunate. That's fine. And they're possessed by their controller. It's coming out of here. Blah, blah, blah. Seeing the body color. They are being possessed. But why are we now failing our simple move to target location? Oh, because I don't have a controller plugged in. Oh, whoops-a-daisy. There's our simple issue. There we go. Also, look at this guy not wanting to move. Alright, there we go. Do that. That goes into there. Actually, no, this has got to go into there. Wait, no. Wait, oh, I have this. I have this a little bit backwards. I just realized that goes into there, and that goes into There. Alright, let's see it. Oh, there's no cities to spawn. That will be an issue. Got to go back to our overworld, hook back up this logic so we're actually spawning cities, because if they find no cities, then what the hell are they going to do? That didn't seem right. That is not right. They are not going to the right locations. Did I hook this all up? Okay, so we don't need this anymore. Get rid of this. Actually, we'll keep this just because we. Oh, Oh, I am doing this. Whoops a daisy. Whoops a daisy, guys. There we go. Hmm. Let's take a look back at a top-down character. Oh. Make sure that this doesn't have to. Oh wait. Get actor transform. Yeah. Wait. No. We want to. Oh. we wanna get this here. There we go. That'll work. What they were doing is they were moving, but they weren't moving, but they were processing logic exactly as I put it to, but it was to tell them to go to themselves rather than the city. But this is now fixed. So this is the first city, so they all ran to it. They're all gonna run to the next city again. Right? Right? No? Is the city off? It might be off the map. Yeah, that's what I was afraid of. It's probably that city off the map. We can actually make it so we spawn the cities a little bit closer within our range. Overall logic, spawn cities. We will do 1,400, 1,400 by 1,400. Okay, so that was the first one. They did get the city as well. They're claiming that city. So this should be the next one they go for, this one right here. Yep. Now you can see like this right here, whenever we spawn these, we actually do want to rebuild the nav mesh. You saw how they were like kind of stuck in there? That's because that was causing issues. So if we actually go in here and we say run console or console execute console command, and we come here after we're done with everything, we spawn all the cities, we're going to say rebuild navigation. And we do need to get a player controller. However, so far we're just a single player game, so just get controller, get player controller. At index 0 is what you need. So what we should see is they should now path a little bit better around the cities, because we're rebuilding the navigational mesh afterwards. However, you notice they're not too good with the player. Let's get the player out of here, because the player itself doesn't update the nav mesh. If you did, you would have to do it constantly every time you moved. Actually, no, it looks like these guys still got blocked. You know what? Why don't... One second. Let's take a look at the spawning again. Let's get this down. Okay, so that is fine. So this should work just even at 10. Good. Okay, so that does work. This should give us better results. should have ran this in Pi. We're not going to see too much usage of it here. F8, hit P. Huh. Did I set it up wrong? Let's just double check. We will go to our city, which I think is the one that we did close. Content. We will go to our city. Nope, not city manager, city. Nav can ever affect navigation, yes. Collision. Character cannot step on it. Generate overlap events. Block all. I'm trying to think why they're having issues. Even with a simple collision, they shouldn't be having problems with that. But I could always calculate it a different way, but that's fine. For right now, it's doing what I need it to. Also, let's see what these errors are. Let's get this fixed real quick. Access none with city manager. Top-down character with... Oh, yeah. So, yeah, that makes sense. City manager doesn't exist when this calls event be in play. So this does. Wow, interesting. Delete this here. We'll keep this because it's just random movement logic, which we might want at some point. So we will use that somewhere else. But anyways, we'll clean this up a little bit here. This will get rid of our errors that we're seeing. Okay. Now what we're going to do is we're going to make it so cities can have a garrisoned unit, meaning that that unit is now a part of it. And we're going to try to be a little bit quick here just because we're running a little bit out of time before I got some stuff I got to do later today, which we're going to go ahead and go into our BP city, and we're going to go ahead and say garrisoned unit. And we are going to turn this into a reference of our top-down character. And we're going to make sure that we no longer make this array, because we only want one garrisoned unit. And their one unit to be designated as the garrisoned unit. And what we will do is we're going to create a new function called garrison. Also, wait a second. Am I in the right one? No, I'm in city manager. I was about to say, I knew something was wrong. The reason why is I didn't see the claim function. I am in the wrong function. I want to go to BP city. Here we go. We'll then call this our garrison. Is that how you... I don't know how to spell garrison. It's right there, right? It's not two S's, right? That looks... Garrisoned unit. If it's wrong, you know what? Someone correct me. I'll pretend like I care, and I'll change it later. This is going to be a reference to our top-down character. Actually, you know what? No, we're not going to make that instanceable. And then what we're going to do is we're going to say garrison as a function. And when we do that, we have to pass it a character. Or yeah, we'll say character, because that's technically what it is for UE4 reasons, but we want a top-down character specifically as the class type. And then what we will do is we will say get, do we already have a garrisoned unit? If so, by the way, this is a different way to do the is valid. Before I was using a different one with a branch condition. This is the alternative. Although we have used this one already. But it doesn't matter if you do this one the other way. They're the exact same thing. And so, yo dog, you are trying to garrison a city that already has a garrison. Also, we're going to do something in this is ultimately going to turn into a state machine, but for right now, we're going to change it to a boolean. It's called is garrisoning. We're going to call it is garrisoning. All right. Anyways, we go back to our BPCD. We're going to say, is this there's a garrisoned unit? Okay. If there's not a garrisoned unit, we will then take this unit here, set is variable, set is garrisoning as true. It is now garrisoning. We are then going to set actor transform on top of where the city is. Get actor transform, which is the transform of the city, because we're plugging in nothing here, which means it gets a reference to self. And because we are in the city class, self is going to be a reference to the city that initializes this logic. So we get the transform, we set actor transform, we're moving the character to the center of the city and being like, hey, yo dog, you're now in the city. However, this is going to cause problems. I need to change this a little bit. We need to break this transform. We then need to do a make transform here. The reason why is because we have a character height offset, which this should be a constant somewhere. However, I'm lazy, so I'm going to do it in a way that doesn't need a constant here, but does gives us a little bit of dynamicy. And that is going to get capsule variable get I gotta figure out what it's called. I can't remember what it's called. Top down character, capsule component. We want capsule half height. Also, I have the last time of this. I think I don't need to have that. I think I messed up. Oh no, wait, we do want it because we're off 48. Okay, yeah. I think we might be fine. PP City. Negative 48. This way they're not flying up in the air. I'm sorry, this is so they're not stuck in the ground, actually. This needs to be added. Because the actor origin, let me show it. Or maybe it's not. Let me just double check. So this is the thing. Our capsule component is our root. It's not basically, it literally is our root, which means the origin of our actor is actually at the origin of the capsule component. So the half height is how much we need to push up our actor so he's actually standing on top of the ground rather than getting stuck in the ground. Get actor transform, blah, 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 blah. Get capsule component. Get radius. Get half height divided by 2. And then pop that value in there. A little bit of dynamicy. Getting a little sloppy here. We need to clean up this code a little bit. And I'm about to sneeze. Gonna mute the mic. I lied. It never happened. It's still partially there. It might happen at any moment. Just a warning, guys. Anyways, we will continue on with this. Going to event graph. What are we doing? What are we doing? Oh, we need to go to our top-down character. What we want to do is, if we are garrisoning, then we will absolutely never, ever, ever move to simple location if we are garrisoning. Because if we are garrisoning, if we move out, we're not garrisoning anymore, right? And we're doing this right here, right before we do the simple move to location. The reason why is because if we do it after, we're going to have problems with the delay. This delay here. And so it's very important that I do it before, immediately before. We're just going to clean this up. A lot of our code is getting a little bit sloppy, and I apologize, guys. I'm used to UE4, but anyone new to this is going to have a little bit of trouble if I leave all of this sloppy. blueprint scripting around. So let's clean this up a little bit, do something more like this. Bring that over there, bring that up here. Something like that, something like that, something like that, and then we move this in. Much cleaner. So just because I like it being perfectly straightened, do that. Go back to BP City, Garrison. We set the character to Garrison. Blah blah blah, and we move them there. Okay. So what we're going to do here is we're actually going to change something as well with this claim. We're going to pop in the top-down character as a value that we're going to pass into this claim, and I can't do that, unfortunately. I can't do it vice versa, though. Wait, no. Well, I don't even have something here that I can do it to. That's fine. We will say... We'll just do it manually. Let's do it the old-fashioned way. Character trying to claim. And then we will call, they claim it, we will automatically make them Garrison when they claim it. Get that character, pop the character in there, easy peasy. We then go to our event graph. Wait, we're missing something. There's something missing. Something's missing. What is it? I forgot about it. What are we missing? There's something very, very important that we're missing. Oh, actually plugging in the class. That's right. Put that in there. Blah blah blah. Okay. Don't know if the positioning is going to work, but we'll find out. Oh, okay. Let's figure out what happened there. Whoops-a-daisy. Wait, no. Get the character, set character actor transform. Let's just get, what the heck? Alright, we messed up the scale somewhere. Oh! Whoops-a-daisy. I forgot to do. I was treating this as if we were in the location. We were adjusting the scale. Okay. We do want the scale of the city, though. We shouldn't have problems with, like, upscaling. So what was happening is they were growing so large that they were pushing everyone off the world. Okay, so let's see. Hey, look. See? Now he's in it. He's now garrisoning the city. And he can't move, but these guys, they want a city. Oh! Red has garrisoned a city. Purple has garrisoned a city. Green is the last one. He must now claim a city. But you know what? Let's claim a city. And now that we claim a city, there's nothing that we can do because we can't navigate. Although, you know what? I don't know why we're turning around, though. But that's fine. But look at that. In just what, a matter of like, let me get the exact time. In the span of 3.5 hours, no, 2.5 hours, in the span of 2.5 hours, we have created an auto-building nav mesh system. We have created an auto-faction spawning system that spawns random locations for them. We have an auto-random city spawning system. We have a way to claim cities. We have a way to garrison cities. We are moving fast, boys. Super quick. 2.5 hours. That's all it takes to do it. Anyone can program it, guys. I promise you, you can do it. You just got to stick with it. 2.5 hours, and we already got a basis of a not so good game, but we do have a game here. So we're probably going to be stopping here, and I'm going to tell you what we're going to be doing next time. Next time, we're going to make it that we can fight each other. That whenever I get close to an enemy or a person of an enemy faction, that we will go in combat. That we will go into third person and we will duke it out. And whichever one wins will survive, and the loser will die. Also, if we have time tomorrow, which we might, we will also look at having squad mates, meaning that in the fight you will spawn in actual AI on your team that will fight each other. Now, I'm going to tell you right now, the AI is going to be pretty basic. We're not going to have like things flying or anything like that. It's pretty much just, move to a spot in front of the target, try to swing a few times. If hitbox, stuff hits, then you do damage. If not, they kind of just idle there. We can even make it so you can process commands like, units of this type move forward and stuff like that. What we'll be doing after that is making it so we can actually change what unit type we are, because ultimately we want it so the player can change what their unit type is. And the unit type will determine what type of attacks they do, whether they do ranged attacks, close attacks, the support, and stuff like that. And we're going to have probably 6 different units, stuff like that. So far, we have 4 factions. We have the Purpulons, the Greenlings, the Redivians, and the Blue Bows. They're very basic, but we got it, guys. Everything that we wanted to do today, we did it. Had a few small hiccups, but I'm happy where we got. And very happy to see where we go through in the future. But for today, guys, we are done. Thank you all for watching. Take it easy. Also, everyone that watches me, they know I always do this. I always give my goodbye, but then I forget. But I have to shut down the stream. It doesn't just close automatically. So I'm always sitting there like an a-hole, as I click it, and it's like, bye guys, and then I'm over here. So I'm going to wait. So I'm over the button. And you know what, guys? We're done for right now. Take it easy.